Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos.
Okay, so I want to do a little bit on implicit differentiation because this is new and isn't in, it depends on how new your book is as to whether it's in it. It's been on the course since 2015. It hasn't been examined yet on the Leaving Cert course. I don't know whether it will this year, but just in case. So the two types of differentiation is what's called implicit and explicit differentiation. So explicit differentiation is where you write an equation in terms of y. So you have y is equal to f of x, some function in x. Okay, so the two examples given here, I'm just using a little handout from Active Maths that's up on the web. Y is equal to the square root of x squared plus 5. So you would get your dy dx, and that's what we call explicit differentiation, and it's the standard one you've been doing. Or something like y is equal to 2x squared cos x, a product rule version. Okay, but what happens when you've got x's and y's in an equation? Okay, how would I differentiate something like that, for example? Well, you actually have two choices. You can actually write it in terms of y. So in this case, I would have had y being equal to the square root of 36 minus x squared, and then you could get dy dx as normal. So that's writing it in terms of y and then just differentiating it as normal. Or you can actually differentiate it using a method called implicit differentiation, and it's really that I want to show you. And the reason I want to show you, I'm just scanning down through examples here just to see what examples are here. If you get a question which has got very high powers of x and y, especially y, so for example, y to the power of 5, then that's much harder to write in terms of y and then differentiate it, okay? Or if you've lots of y terms scattered throughout your equation, it can be harder to write it explicitly then in terms of y and differentiate it. So sometimes there are big advantages to being able to differentiate something implicitly and work from there. Okay, so the types of questions that's going to come up in your course are like more or less written like this. So they will ask you to find the slope of a tangent to a circle. Okay, at a point, or find the equation of the tangent to the circle. So that's what I'm going to do with you. I'm going to do one example implicitly and explicitly and show you that it's the same thing. And then I will do one with the equation of a circle written in this format too. And then I am going to leave that there for a minute. So you can pause the video then on this and do as many examples as you want. Okay, so the next few videos are just that. It's me going down through some of these examples.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice? In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.